Hi guys, welcome back to my YouTube channel. We are still on power series solution of ordinary differential equations. Now, my first video, we go on the higher derivative. Now, let's go on the theorem called Leibniz theorem of n derivative or products of two functions. Now, if y equals to uv, where u and v are function of x. Now, if I am to differentiate this, y equals to uv. Now, I'll take u as my u, v as my v. Then du. Actually, it doesn't make sense saying du. So let's say it's u1 v. Now let's say du dx because they said it's function of x. Now we have du dx to be u1, then dv dx to be what v1. Now if you remember our product rule formula, which is y equals to dy dx equals to u dv dx plus v du dx. Then what's our u? U is the same thing as u. dv dx is v1 plus v is the same thing as v. du dx is u1. So this is dy dx of y equals to uv. Now we can just rewrite it as y1 equal to u1 v plus u v1. Now if I differentiate this again, I hope we remember our Pascal triangle. So if you don't, so we have y 1 1 1 2 1 1 3 3 1. This is for when your x, let's say x plus y is power 0, when you have x plus y raised to power 1, when you have x plus y raised to power 2, then when you have x plus y raised to power 3. This is what we have. This is what you're going to use. Now, using this, if I'm to differentiate this, I will regard this as my x and regard this as my y. Using this formula, it will be u2 v plus 2 u1 v1 plus u v1 1. Because normally we assume that the u here carry the power of 0 and v also carry the power of 0 raised to power 0 0. We assume that it's carry the power of 0. Now, according to what we have here, if you see this one, y raised to power 1, the highest power must be 1. So this is 1 plus 0, 1. 0 plus 1, 1. The highest power is 1. For this one, the highest power must be 2. So that's 2 plus 0. That's 2. 1 plus 1, 2. 0 plus 2, 2. Now, when you go to the third derivative of it, we have u 1, 2, 3, v plus 3. This is what you are using. 3 u will now be 2. V will be 1 plus another 3. Now u here will be 1. V here will be 3. Will be 2 rather. Now plus u will be 0 here and v will be 3 here. So this goes on like that. Now same thing for y4, y5, y6, y7. Now what if the questioner asks us we should find y60? That is, we should differentiate it 60 times. We should differentiate it 60 times. Why are we going to keep solving it like this? No. Now this is what brought about Leibniz theorem, which says that y equals to un v. Remember, I said my v here is 0. So this is yn. So sorry, I have y here. Now what we need to do is that my logic that I use in remembering this formula is that if I differentiate this one, I will have n u n minus 1. We still remember x equals to 2, or yes, x is power n, which give us n x n minus 1. So that's what we use here. So I hope you remember our differentiation. Now let's integrate v raised to power 0. So we have v1 plus, if we differentiate this again, so I will have n minus 1 u n minus 2. If I integrate this, I will have v1 v prime prime. Now we now say all over, if I integrate v1 dv, this will give me v1 plus 1 over 1 plus 1 plus c. So that is v2 over 2. This is what we are going to have. So that 2 here, so we are going to put it as 2 factorial here. Sorry. Now let's go on. Let's move on. Plus, if I differentiate this one again, so I'm going to have n minus 1 n minus 2, n minus 3. So we have v3 here all over 3 factorial, and so on and so on. So this formula is what we regard as Leibniz theorem of nth derivative. That is, if I put any value, if you are asked to find the 10th derivative of of this of this 10th derivative of this, using this formula, I will be able to get it. Now let's take an example. We should find the third when we have y equals to uv. So we have to find the third derivative of it. Now using this formula, so just put it. We are going to use substitutional method. Coming substitutional method. So we have y raised to power 3 into this formula. Anywhere you see n, put 3. So that means 0, 1, 2, 3 v plus 3 multiplied by 0, 3 minus 1 v 1 plus 3, 3 minus 1. Then we have 0 is to be 3 minus 2 v 1 2 over 2 factorial plus 3 open bracket 3 minus 1, 3 minus 2, then u 3 minus 3 v 1 2 3 over 3 factorial. Now we're going to see whether you're going to arrive at this answer. So y3 equals to u 1 2 3 v plus 3 u 3 minus 1, that's 2 v1. So we write it as prime prime plus 3, this will be 2 u, this will be 1 1 2 over 2, then plus 3 multiplied by 2 multiplied by 1, this is raised to our 0. We have 1 2 3 over 3 factorial, that's 6. Now we can see that 2 here can cancel the 2 here, 6 here can cancel the 6 here. So we now left with y3 equals to u 1 2 3 v plus 3 u is 2 here, v1 plus 3 u is 1 here, v is 2 plus u is 0 here, then v is 3. So we can see that after putting our 3 into this formula called Leibniz, we arrive at the same answer as this one. So I hope you understand. Now let's take an example. Example 1. Now find yn when y equals to x raised to power 2 exponential 3x. This is the question we are asked to find. Now before we move on, we need to know the meaning of u, and we need to know the meaning of v. U is the one that the nth derivative can be obtained. Is one that the n derivative can be obtained, while v is one that the derivative is 0. So in this formula, we need to, in this equation question, we need to identify what is our u, what is our v. According to what you have here, u is one that the nth derivative can be obtained. That is why keep when you differentiating it, it will keep increasing. Why v is one that after you differentiate it first, second, third time, it will eventually come to 0. So we can see that it is x that can be my v, and it is this exponential 3x that can be my u. So my u equals to exponential 3x, while my v equals to x raised to power 2. If we remember the formula, exponential ax, y equals exponential ax, which is yn equals to an exponential ax that we wrote in the first video. Now it's the same thing we are going to use here. Now un now we equals to 3n. Our a here is 3. The a here that is here now, we regard it as 3. 3n exponential 3x. That's our un. Now v1, if I differentiate this one the first time, I will have 2x. Now if I differentiate it the second time, I will have 2. If I differentiate it third time, I will have 0. Now it is our v that will determine how long this Leibniz formula is going to be. Now we have to differentiate the nth term of it. Remember, we have un v plus n un minus 1 v1 plus n minus 1 n minus 1 un minus 2 v2 over 2 factorial plus n minus 1 n minus 2 un minus n minus 3, we have v3 over 3 factorial. Remember, v3 is 0, so if you put 0 here, everything here will be 0. So we now left with this. Now let's do substitution now. What is my un? My un is 3n exponential 3x. What is my v? This is my v, x squared dot x squared plus n. What is my, this one says that un, u raised to n minus 1. That means we should minus 1 from the power of un. So it will now be 3n minus 1. It is this 3n minus 1 that will carry the power, not this. You're not going to minus it from exponential 3x. So it is this first one that we're going to minus it. Now exponential 3x. What is my v1? That's 2x. Plus we have n, which is constant, n minus 1 also constant. Now we should minus 2 again. So we have 3n minus 2. What is v2? v2 is 2 over, exponential 3x 2. Now all over 2 factorial. 2 factorial is 2 times 1, which is 2. This 2, we cancel these 2. So we're going to have 3n exponential 3x x squared plus n 3n minus 1 exponential 3x dot 2x plus n minus 1 3n minus 2 exponential 3x. Now we can see that we have something in common. The first thing we have in common is exponential 3x is common. Now you can check that there is 3 raised to n here, there is 3 raised to n minus 1, 3 raised to n minus 2. Now from here, I can make this 3n minus 2 to appear all true. So let's factorize 3n minus 2 outside. Now, you know what we have here is 3 raised to n. Why? We have taken it now as 3n minus 2. So what I need to do is that I need a value to represent this in order to be able to factorize it out. So which value are we going to multiply? Now we have 3n minus 2. We want to get 3 raised to n. So which means that we need to multiply by 3n minus 2 times 3 raised to 2. So if you remember your indices, we're going to have 3n minus 2 plus 2, which is 3 raised to n, because this one and this one will cancel each other. So this means that if I replace this, since I've taken this one, I've factorized this one out now, so I need to replace it with 3 raised to 2. So what I'm going to do now is that we're going to multiply this by 3 raised to 2. Now this one, we're going to multiply by 3 raised to 1, and this one we take it as 3 raised to 0. The logic that I usually use here is that I will take this 3, take it out. Then the power, don't take the minus, we take it out. So you multiply, so you now start multiplying it as I did here, 3 raised to 2. Then this one, we do this with 3 raised to 1, and this one, this with 3 raised to 0. So which means that since I've taken this one out as this, the remaining will be this one. Will be this one. Now we have 3 raised to n. I've taken it out as 3s minus 3 raised to n minus 2. So which means that the remaining part from here will be 3 raised to 1. This one, 3 raised to 0 is still 0, is 1. So that it now remain this and this, because we've taken this one out, taken this one out. So this one will now remain here. So we now have, we know that 3 raised to 2 is the same thing as, let me write it, 3 raised to 2 x squared. That's what we have here. Plus, now we've taken this out by replacing it by 3 raised to 1. Then exponential is common, so it's going to remain 3 raised to 1 n dot 2x. That's what we have here. Plus, now 3 raised to 0, we know that is 1. So we've taken this one out, we've taken this one out. So it's going to remain n minus 1. So if I go further, it will equals to, sorry for this, it will equals to exponential 3x 3n minus 2. 3 square is 9x square plus 3x power 1 is 3 times 2. That will be 6. So you now have 6nx plus, you can decide to open this bracket, which is n square minus n, or you leave it as this. So this is the nth derivative of y equals to x square exponential 3x 3x. Thank you for watching the video.